In this video, we're going to have a look at Pythagoras' theorem and irrational numbers. Let's first of all take the square root of 25 being 5. The square root of 49 is 7, and the square root of 121 is 11. The numbers under the square root are all perfect squares, so their square root results in a whole number answer. The square root of a number that is not a perfect square results in an irrational number. Let's take root 2. Using our calculator, we get an answer of 1.414, let's say 414, rounded to 3 decimal places. The root 2 part is said to be in exact form, and the decimal part is in approximate form. Which is an irrational number. To estimate the value of a square root of a number that isn't a perfect square, we can look at values above and below that are. For example, we know that the square root of 4 is 2, and we know that the square root of 9 is 3. So, making a prediction for the square root of 6, I would guess it's somewhere midway between 2 and 3. Let's have a look on the calculator. The square root of 6 is 2.449. Let's round to 2 decimal places, so it's 2.45 rounded to 2 decimal places, which is what we predicted. We'll need our calculator when finding the length of sides that aren't perfect squares using Pythagoras' theorem. Here we have an isosceles triangle, or two isosceles triangles, and we need to find the length of x. State Pythagoras' theorem, c squared equals a squared plus b squared. And substituting in our values, x being the hypotenuse, and the side length being 5, so x squared equals 25 plus 25, which equals 50. The value of x is therefore the square root of 50, which we'd need our calculators for. If I put it in my calculator, square root of 50, you may be able to see that I get an answer of 5 root 2. That is the simplified surd form, or the exact form. In our case, we want to use the decimal approximation. Rounding to 2 decimal places, I get 7.07. to 2 decimal places. Let's do a second example. Here I want to find the length AC. Again, I have two right-angled triangles. Stating Pythagoras' theorem, a squared plus b squared equals c squared, I'm going to let the unknown side here, being halfway of AC, be x. I'll find x and I'll double the value for the full length of AC. Substituting in a squared for x, plus the other shorter side, 8 squared, and the hypotenuse, 14 squared. X squared plus 64 equals 196. Now I need to subtract 64 from each side. X squared equals 132, so x equals the square root of 132. Again, using the calculator, you'll notice that my calculator defaults to exact form in simplified version, or surd, 2 root 33. We want the decimal approximation, so I get 11.49 rounded to 2 decimal places. Therefore, the length AC is equal to 2 times 11.49, which is 22.98, but that has been rounded to 2 decimal places. So we will need a calculator when working with irrational numbers if we're to give the decimal approximation.